Okay, continuing section 3.4 on parallel and perpendicular lines. Hopefully you've taken into your cell onto your own paper these following problems, and you've worked those on your own. If you've not, take these 4 problems in section or example number 21 and work them on your own, and then come back and listen to the solutions to these problems. Alrighty. Now looking at this first one, we're trying to find out if these lines are parallel, perpendicular, if they're neither. So I want to look at the slopes. That's the first most important thing to tell if 2 lines are parallel, perpendicular, or neither. So the first thing I see is 2/9 for the slope on this first line and -2/9 for the slope here. Well, they're not the same, so they're not parallel. And then they have the opposites, but they're not reciprocals, so that means they're not perpendicular either. So they're not parallel, they're not perpendicular, and so that means they're neither. And that's our answer to this one. So we'll say M1 doesn't equal M2, and M1 doesn't equal the negative reciprocal of M2, and therefore they're not perpendicular. So not parallel because they're not the same, and they're not negative reciprocals, so they're not perpendicular, and that's being quite thorough. Now on our next example down here, we see that we have a 1/2 and a 1/2, so we get excited because M1 is going to equal M2. But remember, when we're looking at parallel lines, we also need to check their y-intercepts. So here we see B1 equals B2. So again, these are neither, because when the y-intercepts are also equal, this means that they're the same lines. And so we can't say they're parallel, they're not. So these again are neither. Now going on to our part C. So the first one here, we have -5/3. Now don't let this worry you that this is written backwards. If you need to, rewrite it the other way. The equal sign's commutative, so to speak, too, and it has this property called reflexive, and it doesn't matter if you read left to right or right to left, they're the same. So M1 here, as looking at it, it's a -5/3, and so I can either look at M2 here and I can say its opposite, which would be positive, and then its reciprocal, which is equal to 3/5. I could do it that way and go, yep, bingo, that's true, and so these things are perpendicular. Or remember, I could do M1 times M2 is equal to a -1, and either one of those will prove that these are perpendicular. And then finally, last but not least here, we have our last example, and we're going to look at the slopes here. So the first thing I see is that slope 1 here is equal to -3. And so I'm going to go down and look at slope 2. Well, slope 1 doesn't equal to slope 2, so that means they're not going to be parallel. So now I'm going to see if they're negative reciprocals. Well, M2 would have to be the opposite of M1, so it would have to be positive, and it would have to be the reciprocal of that, and I see that that's not the case, and therefore they're not perpendicular either. And if they're not parallel and they're not perpendicular, then they must be again neither on these. Alright, so our next example, we're going to come back to the last section, and we're going to find slopes, and then we're going to find the slope of the line parallel and a slope of the line perpendicular. Again, you might want to go ahead and copy down example 22, do it on your own, then come back to the video and check out your answers.